All right, so we're going to look at what is the discriminant. So basically, we can't separate the idea of the discriminant from the quadratic formula. So we're going to have to start there just to get a sense of where the discriminant comes from. And by the end of this video, hopefully it'll make a lot of sense what the discriminant actually discriminates between, because it's named conveniently. So if we look at our general form of our quadratic equation, it has y equals ax squared plus bx plus c, where a, b, and c are just sort of real numbers. They're somewhere on our real number line. So for example, it could be y equals 2x squared plus 2x plus 4, something like that. And on the right hand side here we have a graph of that function. So we've got it's clearly got this sort of parabolic shape. And our question is, one of the questions we can ask ourselves is, what do these values of a, b, and c do? And giving it away a little bit here, but I encourage you to go to Desmos or something like that and graph it yourself to see what a, b, and c do. But basically a is going to make it wider if a is closer to 0, and it's going to make it narrower if a is larger. B sort of slides the curve sideways on its own parabola. So that turning point sort of moves on its own parabola if you change the value of b, I believe. I need to double check that. And c basically changes the y-intercept, moves it up and down, because it's a vertical translation, which you'd be familiar with from linear relations, hopefully. And so those values of a, b, and c are clearly going to change the way that this parabola looks. And what that's going to do is it's going to change the number of solutions that there are. So at the moment, there are 2 solutions. And I think this word solutions can be a little bit confusing when you first encounter it. But the parabola we have here at the moment has 2 solutions. That just means it crosses the x-axis twice. And so, we might want to ask the question, what do we mean by solutions? Solutions to what? Well, it's solutions to this function, ax squared plus bx plus c equaling 0. So we're interested in where does this line cross the x-axis? And so that's what we call solutions. So that's what we mean when we say that throughout the rest of the video. This is where the quadratic formula comes in, because the quadratic formula tells us the answer to that straight away. And here it is, in case it hasn't been tattooed on your forehead already. X equals negative b plus or minus the square root of b squared minus 4ac on 2a. Now it can be a little bit confusing, but these pink points here are described, the x values of these pink points are this, negative b plus or minus the square root of b squared minus 4ac on 2a. And you can see that there is 2 solutions in there, right? You've got a plus or minus, so that's sort of taking you to the left and to the right, which is clearly where we have our 2 solutions here. Okay, but clearly that the solutions depend on these values of a, b, and c, right? And so what the discriminant is if we zoom in a little bit just into this part underneath the square root, b squared minus 4ac, that discriminates between the different kinds of parabolas we can have, namely how many solutions they can have. And so let's dive into that a little bit more. This box here just says, the values of a, b, and c tell us how many solutions we're going to have. But if we zoom into the discriminant, which is just the part underneath the square root, we get b squared minus 4ac. And it tells us the roots before we have to actually find them, before we have to plug it into the quadratic formula. It's going to tell us how many there are, because there's a special feature of square roots that you'll be aware of. You can take the square root of a positive number. The square root of 0 is just 0, and the square root of a negative number at the moment we can't do. It doesn't have a real solution. So the discriminant tells us basically how many solutions there are. And if we sort of break down the quadratic formula a little bit more, you could imagine that we split this quadratic formula up into 2 parts. So it's negative b on 2a plus or minus the square root of the discriminant on 2a. So that negative b on 2a might sound familiar from your study of quadratics. That's actually the axis of symmetry. So on this quadratic here, it's the vertical line around which the function is symmetric. And so clearly in this graph here, the y-axis is the line of symmetry. So negative b on 2a in this case would be equal to x equals 0, would be the y-axis there. And so that negative b on 2a is always going to be our axis of symmetry, and then the plus or minus the square root of the discriminant on 2a takes us to the left and to the right of that axis of symmetry, and it tells us where the x-axis solutions will be. So hopefully, maybe starting to piece it together a little bit. I want to show exactly, some examples here. So if A was 1 and B is 0 and C is -3, then the discriminant is 12 because B squared is 0 minus 4 groups of 1 times -3. So -4 times -3 is 12. So we get a discriminant that is positive. And so basically in the quadratic formula, that part there does not go away. So we do have a plus or minus of something. So that's going to take us to the left of the axis of symmetry and to the right. So we've got two solutions. So it cuts the x-axis twice. So, we change it and then things change though, right? If we have one solution, say for example, A is 1, B is 0, and C is 0, the discriminant becomes 0, take away 4 times 1, which is not 0. Hang on, one sec. Sorry, what am I talking about? I was trying to do quick maths too quickly. Yes, this does go to 0. If B and C are 0, you get 0 squared, which is 0, take away 4 times 1 times 0, which is also 0. And so we end up with a situation on our parabola where we just touch the x-axis once, because that square root part, the square root of 0 is 0. And so you're just left with your solution being the axis of symmetry, which is -b on 2a, and the other part falls away. It's not there anymore. And then, again, we tweak the values of a, b, and c, and we make the discriminant negative. So if a is 1, b is 0, and c is 2, we end up with a discriminant of -8, and clearly we can't take the square root of -8, so the whole thing is undefined, or basically there's no solutions for x. And so we end up with a parabola like we have here that doesn't cross the x-axis at all, which is neat. It's interesting. And you can do all sorts of other things. Obviously, if you have different values, you can go back to 0. Yeah, if it's positive, you have two solutions, as we spoke about. Yep, two solutions still. If we change the value of a, it makes it wider. Interestingly here as well, if a is 0, it's not a quadratic, because you can see that 2a is in the denominator, and you know that we can't divide by 0. So if a is 0, we don't have a quadratic, and so there's no solutions. And so, the maths kind of breaks down. We end up with a horizontal line. So yeah, one of our conditions is that a is not 0 for a quadratic to exist. And then if a is negative, or say it's -1 and b is 0 and c is -2, that a value, if it's negative, it flips the parabola the other way around. So you're hopefully starting to see how, it all connects together, how the discriminant discriminates between different kinds of parabolas, in particular, how many solutions they have. And here's the summary, right? This is the golden ticket. If the discriminant is positive, we use this delta. I don't even explain that. Delta for the discriminant is greater than 0. You have two solutions. If it's equal to 0, you have one solution. And if it's less than 0, you have no real solutions. And remember, these can all obviously be sad faces as well. They're all happy faces at the moment. Okay, two things worth knowing. If the discriminant is a perfect square, the roots are rational. Now, I encourage you to think about the perfect squares. You probably learned about that before. Basically, the quadratic factorizes very neatly, and you get rational solutions. Basically, that means there's no surds in your solutions. And, at the moment, this is not super important, but if the discriminant is less than 0, we said there's no solutions, like we have over on the right here. In specialist maths later on, you can think about imaginary solutions, because you can start to take the square root of negative values and you get two what's called complex conjugates. Don't worry about that for now. Although, we do have plenty of videos on that fun stuff as well. But yeah, the discriminant decides how many answers there are before you work out what they actually are. So it does this discrimination for you, and it can be a good sanity check, because you're trying to solve these quadratics and you're like, oh, how many solutions am I going to have? I'm going to have 1, 0, or 2. And the discriminant can tell you whether the kind of working out you're doing is working out. That was a bad way to phrase it. Very good. Good stuff. Good luck with everything you're doing, and I'll talk to you soon.